infections, but when they get an opportunity, especially during immunocompromised state, can produce severe infections. So some examples of opportunistic GI parasites includes the coccidian parasite. So you have heard of the coccidian parasites and some coccidian intestinal parasites. Examples are Cryptosporidium parvum, Zoospora, Cyclospora, etc. So these parasites, when they occur, when they produce infection, they can simply produce minor infection during in immunocompetent patient. But in immunocompromised patients, especially AIDS patient, they produce severe and prolonged illness. So, thus parasites are generally these parasites are therefore indicated as opportunistic GI parasites, especially in AIDS or sometimes in other immunocompromised patients. So, I'll be discussing those parasites. Okay, one of them is the Cryptosporidium pardon. So, the group of the parasite is the coccidian parasite. As the phylum is the Apicomplexa, the phylum to which the Plasmodium belongs to. So the phylum is Epicomplexa and the subclass is the Coccidia. So this coccidian parasites, that is the subclass Coccidia, these parasites occur as an opportunistic parasite, especially in immunocompromised patients. Cryptosporidium parvum. This is a coccidian parasite. So the parasite today I'll be discussing is all of them are coccidian parasite and therefore they are protozoan parasite. Okay, so Cryptosporidium is also a coccidian parasite belonging to the phylum Epicomplexa. So the phylum is Epicomplexa, subclass Coccidia. So Cryptosporidium, Zoospora, Cyclospora. I will be discussing these three parasites. All of them belong to the same group and they'll have a similar clinical presentation, similar life cycle. Right? And the disease therefore is called cryptosporidiosis. And this infection can occur in humans or other animals, especially cattle. The cattle can be a source of infection to humans, and the source of infection is mainly the contaminated stool, so the stool of the host. And the disease is called cryptosporidiosis, and it was first reported in 1976. So this is not a very old disease. It was first reported in 1976. So it can produce infections even in the immunocompetent, but infection is generally self-limiting, or most of the patients are asymptomatic. And it produces commonly it produces symptoms in immunocompromised persons. Therefore, it is indicated as one of the opportunistic pathogen in immunocompromised patient, especially AIDS patients. So when you're thinking of when you have an AIDS patient complaining of prolonged and severe diarrhea, we may think of the positive agent to be this type of parasite. The infected dose is around 132 oocysts. So the infected stage is the oocyst, which is correlated, and this oocyst, the infected dose is around 132. If we at one time, if we ingest around 132 oocysts, then it can produce the clinical manifestation. And since the source of infection is contaminated food and contaminated water, and if we treat the water with chlorine, these parasites will not be destroyed. So these parasites are resistant to chlorine. So we may prefer the method of filtration over chlorination to disinfect the water we drink to destroy these types of parasites. And common species is parvum. Cryptosporidium parvum is the one that infects the humans. Mainly, the source is the cows or the bovine animals, which infection occurs to the humans. So contaminated water, uh, contaminated with the oocysts from the stool of the cows and buffaloes. If consumed by humans, they produce infections. So sometimes this infection can also be considered as a zoonotic disease. So there are many species of Cryptosporidium that produce infection in different other animals, but the one that is associated with human infection is the parvum. The Cryptosporidium parvum, it is a coccidian parasite that is associated with uh, intestinal infection in humans and commonly in the AIDS patients. So it can be a cause of persistent diarrhea in AIDS patient. And the habitat is the small intestine. Commonly, the site with this parasite site can be the small intestine. It is the site of this parasite. The infective stage, I said, is the oocyst, which contains the sporozoid. So oocyst, the morphology of the oocyst is spherical in structure, or it can sometimes be oval, and the size is around 2 to 8 micrometer. And inside it, it contains the sporozoids. Like the plasmodium also, it contains the sporozoids. So the sporozoids are the infective stage. So the oocyst that contains the sporozoids inside is the infective stage. So oocyst can be unsporulated initially, and when it is passed out in the stool, it becomes sporulated as it develops the sporocyst, and the sporocyst inside develops the sporozoids, and these sporozoids are the cause of the infection. So oocysts containing the sporozoids are the cause of infection. Right? And the property of these parasites of these oocysts are they are exit fast. So all of these three parasites, the oocysts are exit fast. That is, they are Zn stain positive. So when you then with the Zn stain, concentration of decolorizer is weaker, so they are weak acid fast. We take around 1% of the H2SO4. We can take HCl, and on microscopic observation, we can see the acid fast oocyst of this parasite. So one feature is these parasites are weak acid fast. There is difference in the size of the oocyst. So all of them have a single stage, and they carry out their life cycle, both sexual and asexual life cycle, in a single host. And this oocysts are acid fast, one of the property. But there is a difference in the size of the oocyst. Cryptosporidium, crypto means small, so cryptosporidium, the oocyst is the smallest among the three. Yeah, the size is only around 4 to 5 micrometer. The life cycle, as we can compare it to the life cycle of the plasmodium for remembering it. So it is similar to as that of plasmodium, and the infective stage is the oocyst. It contains the sporozoids, and infection occurs through the consumption of the oocyst. So the oocyst is passed in the stool. It gets it is spored in case of cryptosporidium. The oocyst is self-sporulated as it is passed in the stool, and it contains the sporozoids. We consume the oocyst. Then inside our intestine, when the oocyst gets existed, as the cyst wall ruptures, the sporozoids are released, and then they invade the intestinal epithelial cells, and there they carry out the asexual and the sexual life cycle. So the sporozoids are released. The sporozoids convert themselves into tropozoids, tropozoids into cyzones to merozoids. Merozoids, so sporozoids, tropozoids, cyzones, and the cyzones form the merozoids. First generation of merozoites in the first infected cells. The first generation of the merozoites then invades the other epithelial cells of the intestine. And then they again carry out this sexual cycle, or some may enter into the sexual cycle, producing the gametocyte. So microgametocyte and macrogametocyte, they produce the gametocytes, male and female gametocytes. They fuse to form the zygote, which forms which is the oocyst. So that is, we can compare it to the life cycle of the plasmodium. Okay, now that oocyst then again becomes sporulated. It will contain the sporozoids inside. That oocyst is passed into the feces, can contaminate the water, and that if you consume that contaminated water, it can be the source of the infection. In case of cryptosporidium, the oocyst can be of two types: thin-walled and thick-walled. So if the oocyst, in around 20% of the cases, the oocyst can be thin-walled. So if the oocyst is thin-walled, because as the wall is thin, it can easily be ruptured, so the sporozoids can be released, and again it can enter through the capillaries, and again um, reduce the infection in thin patients. So in cryptosporidiosis, auto-infection can occur in around 20%. Okay, so this is the life cycle. So the oocyst is passed in the stool, and it is consumed. It develops into this. It releases the sporozoids. Sporozoids develop into the tropozoids. Tropozoids into the merozoids, and then it enters into the sexual life cycle. So merozoids, the first generation, develops the second generation merozoids. That is when it infects the other epithelial cells. And this merozoites then develops the gametocytes, so micro and macro gametes, and fuse to form the zygote, which is the which develops into the oocyst. That is the life cycle of Cryptosporidium parvum. Let's look in another figure. The clinical manifestation, I said, so this is a GI parasite and it is associated with diarrhea. So it can produce watery diarrhea associated with nausea, vomiting, abdominal cramps, and low-grade fever. But most of the patient can remain asymptomatic. The disease can produce minor symptoms. It can last for a few days, and the disease is self-limiting. But in immunocompromised patient, it can produce severe diarrhea. So the diarrhea can cause loss of huge amount of water and electrolyte, and that can be associated with weight loss, anorexia, muscle pain, etc. So it can produce chronic and severe diarrhea, therefore debilitating the patient. And that is an immunocompromised patient. And it can further produce other conditions like the respiratory cryptosporidiosis, can be associated with cholecystitis, hepatitis, pancreatitis, etc. The pathogenesis is probably thought that this parasites now when it invades the intestinal wall, then it causes production of the cytokines and macrophages, and so it produces inflammation in the intestinal wall and cell mediated inflammation, and also villus atrophy, hyperplasia. So that is the result of that can cause malabsorption because of the inflammation, atrophy of the villi, and hyperplasia. It can produce, can inhibit the absorption of the nutrients. That is loss of electrolytes into the intestinal lumen, therefore producing diarrhea, and therefore it is associated with malabsorption. Diagnosis. For diagnosis, any type of GI parasite, main mode of diagnosis is the microscopic examination of the stool. You can take three consecutive samples because a single sample may not be able to demonstrate the toxicity of the parasite. So we can prefer collection of three consecutive samples. Then you prepare the wet mount of the stool sample of the suspected patient and toss for the cyst. And these oocysts are round, oval, or spherical structures measuring around 4 to 5 micrometers. So smaller than slightly smaller than the size of an RBC, or almost equal to the size of the RBC. And next we can perform is the modified density. That is, parasites are weak acid fast, and they will appear reddish in color. And another technique we can use the immunofluorescence microscopy, etc. So mainly we do is the Zerenstein and the wet mount. So you can see the parasites, you can see the rounded refractile structures in these two samples. And these are the oocyst of Cryptosporidium parvum. And this is the Zerenstein, and the parasite is variably Zerenstein. So some oocysts may appear bright red, some may appear faint red, or some may even not be seen. Zerenstein for the parasite, modified Zerenstein for this parasite is also positive. And this is the immunofluorescence. The smaller rounded one is the oocyst of the Cryptosporidium parvum by immunofluorescence technique. And treatment. For self-limiting illness, we may not require the treatment. We can just provide the supportive care, or we may not require any treatment. Especially treatment is mainly for those who have severe infection, and we have to provide fluid replacement, other supportive treatment, and the drug of choice is mainly nitazoxanide. So it's around the dose is around 500 mg twice daily, 3 to 5 days. We can use other drugs like paromycin, spiromycin as well, but the drug of choice is nitazoxanide, and we may require to prolong the treatment if necessary. And another parasite is Cyclospora cadenensis. So the life cycle clinical manifestation of this parasite is similar, and the diagnostic mode is also similar. And all of the for the diagnosis of this parasite, we look for is in Oocyst of these parasites in the weight mount, we can perform the ZN stain, but all of them are ZN stain positive. They are ZN acid fast organisms. So it may be difficult to differentiate between these parasites. Isospora is have a larger oocyst, and the shape is also different. So it may be easier to differentiate the isospora, and it is also less common. But cyclospora and cryptosporidium, the size is also not much different, and both of them are acid fast, so it may be difficulty in differentiating the parasite. However, we have to differentiate because the choice of treatment is different. It is fluconazole for cyclospora, and nitazoxanide is the drug of choice for cryptosporidium. So when we are observing the parasite in the stool sample, so we have to observe with care. The next parasite is Cyclospora catanensis. Again, this is a coccidian parasite. Subclass is Coccidia complexa. The disease name is given as cyclosporiasis. It was first reported in 1985 in Brazil. So the parasites were reported just about more than a century back. These are not very old parasites, and this is also a parasite more common in immunocompromised patients. Therefore, it is being indicated as opportunistic pathogen, and it has been reported from Nepal, India, South America, etc., where it can be found worldwide. And it is a parasite commonly residing in the tissue. And cyclospora is thought to be occurring inside the epithelial cells within the cytoplasm of the epithelial cells of the gastrointestinal tract. And the infectious dose is thought to be low, but yet not known. Right? And this parasite is again resistant to chlorine, so we can prefer filtration of water to remove the parasite from the contaminated water. The structure, the morphology is of the oocyst. So oocyst is the stage of this parasite. It is again spherical in shape and sizes a bit larger than that of the cryptosporidium. So spherical structure, size around 8 to 10 micrometer, and it will again have the sporozoids inside. Oocyst is two sporocysts inside, and each sporocyst containing the sporozoid, and the sporozoids cause the infection. So you can see the oocyst with the sporoblast inside, upper left one. Again, clinical features is again similar. Patients are generally asymptomatic, or they can present watery diarrhea, abdominal pain, and the disease is generally self-limiting. But if the patient is immunocompromised, the infection is severe and prolonged, and relapse or recurrence is high. And now, the pathogenesis of the disease, the parasite again, it causes the inflammation of the lamina propria, villus atrophy, and hyperplasia, therefore causes malabsorption and diarrhea. So this is the life cycle. Life cycle is again similar. The oocyst is passed in the stool of the infected patient. The oocyst is initially unsporulated. Generally in cryptosporidium, the sporulated oocyst is passed, but in case of isospora, cyclospora, generally unsporulated oocysts are passed, which is not infective, and in the environment, within around 1 to 2 weeks, they become sporulated. So they develop the sporozoids inside, and these sporulated oocysts are the source of infection. Now they are consumed along with the contaminated food and water, and especially fresh fruits and vegetables are considered to be the source of infection. So those fruits, like for example, as in this figure, the raspberries, leaves like the basils, they can be contaminated with the oocyst. So if this fruits and vegetables come in contact with the infected patient or the infected contaminated water, then these are the common source of infection. And when you ingest the oocyst, then inside the intestine, again the sporozoids are released, and these sporozoids develop into the tropozoids to the merozoids, and the first generation of merozoids enter into the next epithelial cells, develop the second generation of the merozoids. Again, merozoids can continue the sexual cycle, or some merozoids again develop the enter into the sexual cycle, producing the gametocytes, micro and macrogametocytes which fuse to form the zygote, and the zygote develops into the oocyst, and these oocysts are unsporulated. These unsporulated oocysts are then passed in the environment, and in the environment they become within 1 or 2 weeks they become sporulated, and they are the source of infection. They are the cause of infection. The development of the cyst inside the intestinal epithelial cells. Again, for diagnosis, microscopic examination of the stool sample, the weight mount, we prepare the weight mount, we look for the oocyst, and while observing the oocyst, we have to differentiate between the oocyst of the cryptosporidium and the cyclospora. So one thing we focus is on this side. So there's a slight difference. So the oocyst is spherical, and generally the outer side is very non-refractile, and the inner part of this is refractile. So it has a spherical structure or non-refractile sphere with refractile globules inside. So cryptosporidium as a whole can appear as a refracting structure, and in case of cyclospora, the size is again slightly different. It is larger, and rather than the outer part, the inner structures appear more refractile. And we perform the ZN stain, again the parasite is acid fast. And we can also perform PCR and jejunal biopsy, though they are not routinely done. For is the microscopic examination. This is the parasite, spherical structure. So you can see this parasite with the inner structures. So with is the chloroplast or the sporocyst, and this is the ZN stain. So the parasite is slightly larger as compared to the cryptosporidium. And therefore we have to differentiate because they produce a similar clinical manifestation, and on diagnosis also the microscopic examination may not be easily distinguished because of the similar structures, slight difference in the size, but we have to differentiate between these two parasites as the treatments are different. The treatment is cotrimoxazole. It was nitazoxanide, a different group of drug for cryptosporidium, whereas cotrimoxazole twice daily for around 7 days is the treatment of choice for Cyclospora cancrensis. The next parasite is Isospora billi. This is less common as compared to the other two. This is now called the Cytoisospora, and it is again a coccidian parasite. It has also been commonly reported from AIDS patients, and it has been found in countries like Africa, Southeast Asia, and mainly India, South America, Central America, etc. And it is again a parasite of the small intestine, mainly the jejunum. The morphology of the oocyst is elongated, so the shape is slightly different. It is spindle or oval in shape. It has an elongated shape, and size is also larger, 22 by 15 micrometers. So the size can range around 20 to 30 micrometer by um, uh, 15 to 20 micrometer, and it will again have sporozoites inside. So the oocyst will have two sporocysts inside. The two sporocysts, each of them will have the sporozoites inside. And again, this is the life cycle. So the source of infection is fecal root transmitted through the consumption of the contaminated food and water. And the oocyst is consumed. And the oocyst is consumed in the intestine. The sporozoites are released. The sporozoites develop into the trophozoites, merozoites, and they develop into the enter into the sexual cycle, developing gametocytes. And these gametocytes fuse to form the zygote, which develops the oocyst. Now this is passed in the stool, and now in the environment, and the oocyst becomes sporulated. So they develop the sporozoites in the environment, and the sporulated oocyst then becomes the source of the infection. When symptoms is again similar, patient is commonly asymptomatic. Severe diarrhea, especially in immunocompromised patient, because of severe diarrhea, it can produce weight loss, anorexia, muscle pain, etc. And again, diagnosis is the weight mount, which is the oocyst, and the pregnancy. So this is the comparing picture of the three parasites. The first one is of the Cryptosporidium parvum, which is Wallenstein positive, and the weight mount, it is smaller as compared to the other parasite. Cyclospora, when it is Zeran positive, the size is slightly larger. The next one, the below one, is of the Isospora. The Isospora we can differentiate easily from other parasites because of its shape and its larger size, and it is also acid fast. And treatment, this is Artemoxazole twice daily for around 2 to 3 weeks. These are some of the parasites that can occur as an opportunistic parasite, especially in AIDS patients or even in other immunocompromised patients. So these are coccidian parasites which have a similar life cycle and common clinical manifestation, that is mild diarrhea in case of immunocompetent and severe and prolonged diarrhea in case of immunocompromised like AIDS patient. And treatment of the two parasites is cotrimoxazole or as cryptosporidium is nitazoxanide. So there's a difference in the treatment of cyclospora and the cryptosporidium. And so the appearance under the microscopic observation, they will have they may appear similar. It may be difficult to differentiate, but we have to differentiate, especially based on the size of the parasite. Is it okay?